Hey everyone, it's Miss Lloyd, and we are looking at vectors on a plane, not snakes on a plane, but vectors. So when it comes to vectors, you may think of the little guy in Despicable Me, who was a supervillain who went by the name of Vector because he committed crimes in both direction and magnitude. And then he did the weird hip thrusts, and that was kind of awkward. But I mean, you have to have awkward villains. Otherwise, how do we not like them? Although I'm awkward, does that make me a villain? I don't know. Anyways, so a vector is any quantity that has both direction and magnitude. Sometimes that magnitude is going to be size, sometimes it's a force that is being exerted, sometimes it is a speed that is happening. So there's a couple different options depending on the context of the problem. Also, some special things about vectors. It is represented by an arrow. The arrow's length is going to be proportional to the magnitude. So the higher the magnitude, the longer the arrow. And then the arrow's direction is going to be the same as direction given. So if we say, here's my little coordinate plane, and we have a vector that is at 45 degrees, then it's going to go through the 45 degrees. And I don't know, maybe it's something that's going 5 miles per hour. Probably me on a bike trying to go up a hill and then eventually dying because I don't go up hills, especially on my bike. The component form of a vector, so we're looking at the x comma y. So if we have 2 points, so there's our initial point where we start and then our point where we finish, our vector is going to be kind of the distance for each of those. So the distance we went along the x and the distance we went along the y. So it's the distance of x comma the distance of y. Often you will see, depending on the book or the website that you're looking at or whatever, these vectors can either have the little arrows on top to show that it's a vector, or sometimes it's just a very bolded letter to indicate it's a vector. So we have a couple options. I personally like to do the little like half arrow thing because I think it's cute. It's like it's got a little hat. But yeah, that's just me. And then in order to calculate magnitude, we're talking about the length of the arrow. So if we're talking about the length of the arrow, the length of the vector, then we're just doing like basically what we've done. We found our y value, we found our x value using this over here, and then we use that y and x in order to figure out the hypotenuse over here, which is our magnitude. So the magnitude is basically the hypotenuse, and your v1, v2, or that length comma length of your vector is basically the legs of a right triangle. And if our magnitude ends up being 1 whenever we do the solving, then that means that our vector is a unit vector. So it ends up being 1, then it's just a unit long. So we have a unit vector. So all of our little values in the in the unit circle, sorry, all of our values in the unit circle should end up having magnitudes of 1 because they're all part of the unit circle, and that radius is 1 every single time. So you're basically kind of finding that radius, if you will. So the first example that I'm going to go over, it wants us to find the component form. So it wants us to figure out basically the lengths of the sides of a right triangle. If we are starting off with our initial point as 1 comma 7 and our terminal point is 4 comma 3. And my students will tell you, I'm a stickler about labeling things. So because I want to follow the formulas, if we're just now using this, vectors are completely new to my students, so we're going to kind of take it slow. I'm going to have them label these P1, P2, and Q1, Q2. So then we can plug that in. So remember, we're looking at the distance we've gone along the X, comma, the distance we've gone along the Y. So in order to find that, and it does label, I'm going to label that vector V. So I'm going to have my little V with the arrow because the arrow is cute. And because we are not talking about an x comma y, we are looking at a length comma another length. We are not using curved brackets, parentheses. We are using these like pointy brackets instead to indicate that it's a vector and it's a length comma length. And then I'll simplify. And here you have our component form. So I've got my component form, and now it wants me to find the magnitude itself. I really like finding the component form first and then doing the magnitude because then I can skip this first part of finding the magnitude and I can just plug everything into the second one. Since I have my v1, v2, I don't have to use q and p anymore. So I'm doing, this is basically finding the hypotenuse of the triangle this makes. So I'm doing the length of one leg square plus the length of another leg square, and I'm taking the square root of that in order to find the hypotenuse. And I get a nice pretty number. This doesn't happen all the time. It actually kind of rarely happens, but we're starting off, so we're going to go a little bit slower. I'm going to save the next bit for my students. Next, when it comes to vector addition, so we're adding two vectors together. Basically, we're adding the x's together, adding the y's together. So we've gone one vector and then we've gone another vector. We've started in one position and then gone another. And so we're trying to figure out this total distance it's gone. So we'll just add those x's together to figure out that total distance, add the y's together to figure out that total distance. So remember, these are just looking at the distances that you're going along the x and along the y. There are these few properties, so if you're adding them together, it doesn't matter if it's u plus v or v plus u, you're going to end up with the same thing. If you add 0 to a vector, you're going to have the same vector. These are all basic addition rules, and these properties for basic numbers also apply to vectors. When it comes to scalar multiplication, we're doing some very basic distribution. So if you're multiplying a vector by any number, you're going to distribute that in. One thing that we do want to be careful of when it comes to the magnitude, we are taking the absolute value of that number that we're multiplying the magnitude by. So when we're multiplying those magnitudes, we do want to be careful. All right, so then here, they've given me u and v as my vectors. So I don't have the ability to put little hats on them just by typing it, so I'm just going to put the little hats on them now. Little arrow hats. I think they look adorable. New York Fashion Week, look out. And of course, I'm going to do some labeling. And so I know that these are distances because these are the vectors. This isn't an x comma y. We can see the pointy brackets here. And so I know that that's the distance it went along x and the distance it went along y in order to create the vector u. So remember, the vector u is actually would probably be more like this if it only went a distance of 1 here and a distance of 4 there. And so we're going to be adding these two together. So if I'm doing u plus v, I'm going to add the x distances first, comma, I'll add the y distances. And we simplify and we're done. That's simple. I'm going to save the others for my students. If we are doing some multiplication and notice that these are inside the double bars, that means that we're multiplying 3 with the magnitude of u. So first, if I'm going to multiply 3 by the magnitude of u, I need to figure out the magnitude of u first. So I've plugged this into the formula for the magnitude, and this is one that doesn't end up very pretty. We end up with just a square root of 17. I can't simplify this, so this is what I'm stuck with. And so when I'm doing 3 times that magnitude, it's basically going to be 3 times my square root of 17. I can't combine this anymore. I can't simplify it anymore. We could find the decimal, but it's not really necessary. I want these to remain as square roots, simplified as possible, so we're done. When it comes to unit vectors, this means that I have a magnitude of 1. So a way to find that is by rewriting the vector so that I have the lengths of the vector on top, so like the length of the x value, comma, length of the y value, and then divided by the magnitude. And this, whenever I plug it in, will give me a magnitude of 1. So for this first situation, they give me my vector v. So I know I have a v1 and a v2. And we want to rewrite this in a way so that my magnitude, or so that I can create a unit vector that would be 1. So before I do that, I have my length of the x, comma, length of my y. I need to figure out what the magnitude of this is. So then I can divide each of those, and then I'll prove that that new vector is a unit vector by finding the magnitude of it again. So I found my magnitude of my vector v. So I'm going to plug this in so that I can find the unit vector for this scenario. So that means I'm basically just taking the x value of my original vector, putting it over that new magnitude, and doing the same thing with my y. So this here is my unit vector, and I'm going to prove here in a moment how it is a unit vector by finding the magnitude of this vector. And so since this magnitude is simplified down to 1, then I know that I have done this unit vector correctly. The next we're going to look at is the standard unit vector. So there's the component form, which is inside the brackets. So I'm going to first find the component form inside my pointy brackets. If I have a starting point at -2, 6 and a terminal point at -8, 3. And then I'm going to show you guys what the standard unit vectors is. And I know it sounds like, oh my gosh, another thing, but I promise you it's super simple. So for this first bit, I'm just finding the component form. So that means I'm finding the distance between the x's and the distance between the y's. Now that I have my vector, so I know my vector u, in order to put it into the standard unit vector, I'm basically, it's just another way of rewriting it. It looks exactly the same almost. So I have my distance of the x, so what we found for -6, and that's going to be represented with my I. And then, in this case, it would be minus because I have that -3 with the j. And so that's pretty much it. So this is telling us the distance we went along the x and the distance we went along the y, just a little bit different presentation. And so this is our standard unit vector. So when it comes to the direction of our angles, we have our x comma y. When we're working with the unit circle, we also see that as cosine comma sine of whatever our angle is. And so in order to determine our direction, we can use that tangent knowledge that our tangent is sine over cosine. We can always use the inverse tangent in order to find this. If we know the distance that cosine has gone, the distance that our sine has gone, so the distance of x, the distance of y, we can figure out what our quadrant is in and then determine what our angle will be. We also have our component form of this direction. So if we know our angle, if we know our direction, we can plug that in for theta, and then we can multiply that distance, which would be our cosine of theta, plugging that into our calculator. The y distance would be sine of theta, plugging that into our calculator, and then multiplying that by our magnitude, and that will give us our component form if we're given our angles and our magnitudes. We want to find the direction of our angle. And so they've given it to me in the standard unit vector form. That means that I have an x value or an x length of -6, a y length of +6. And so that means I have a cosine of -6 and a sine of +6. If I'm -6 along my x, +6 along my y, I know that this is going to be in quadrant 2, which means I'm looking for an angle in quadrant 2. So I can plug this into my tangent. My tangent of my angle is going to be sine over cosine, so that means my 6 over my -6. When I simplify this, that means I'm looking for when tangent theta is going to be equal to -1. Luckily, we know that in quadrant 2, tangent is negative, so I know I'm still looking for a quadrant 2 angle. Also, I know that this is something that's really pretty in the unit circle. So I could use inverse tangent if I wanted to, if I can't think of the angle right off the top of my head. I do know that if it's a tangent with 1, then it's a 45-degree reference. If we're in the second quadrant, then this is going to be 135 degrees. The rest of my examples I'm going to save for my students. I hope you guys found this helpful. If you did, please like and subscribe. And if you think this could be helpful for someone else, please feel free to share. Spread the love.